Okay, in this section on symmetry, it's going to be really important that we review the vocabulary before we get into any of the questions. So we have different types of symmetry. Translational symmetry, it says it can be created by translating a figure or a group of figures without using a reflection or rotation. Translation with these arrows is basically that we're just sliding a shape over to another position. So like if I took this shape and slid it this way, I would get this lighter one. If I took this shape and slid it to the left, I would get this. If I went up and over a little, I would get that. So you're just sliding it over. Okay, I know this example didn't really come out super clear, so it's kind of hard to see because some of the copies aren't great. But if I took these three, and they're supposed to be suns, and slid it over, I would get this shape. And then if I slid it over again, I would get this shape, and there would be a third one here. So it's just like moving it over, sliding it across. Okay. These arrows that show the direction that you slide it are called vectors. Okay, so those arrows are called vectors. So these are vectors. It just shows which direction you're sliding. So in these examples, it says determine whether each figure or pattern has translational symmetry. If so, draw the translation vectors. Explain your reasoning. So we're wanting to look at, can I take one of these shapes and just slide it over and get the other one? So this is not going to be translational because I can't just take the shape and slide it over and get this one. I'd have to also do some kind of turn, some kind of rotation, or I'd have to like flip it over. So this is not translational symmetry. Okay, for this one, we have a bunch of hexagons, okay, and these hexagons, if I slid it down, would go exactly on top of this one. So I could show that I could slide this one down here, and I would get that shape. I could show that I could slide this one down and over a little bit, and I would get that one. And I could show that I could slide this one over to get that shape. So those are some examples of how I could show the vectors. It doesn't necessarily have to be that way. I could have started at the bottom and said I slid this one up here, this one up, and this one over. So there's more than one way we can do this problem. So this one does have translational symmetry. Okay. Then we have some other symmetry on the back. We have reflectional symmetry or line symmetry. They mean the same thing. Okay, if there's line symmetry, we can flip something. So I think of the word flip over a line, and it would create the same shape. So if you want to think of either like flip or fold, like if I took this paper and I folded it on that dotted line, this shape would sit exactly on top of that one. Okay, so I basically could cut it in half and it would fit exactly on top of there if you folded it up. Okay, so sometimes there's more than one line of symmetry that can be drawn in a figure. In this figure, this pentagon, it says determine whether each figure has a line of symmetry. If so, draw the lines of symmetry and state how many it has. So I could cut this pentagon in half like this, and if I folded on that line, the left and the right side would sit exactly on top of each other. I could actually do that through any of these vertices. So I could fold it that way on the pink line. I could fold it through this vertex. I could fold it through this vertex, and I'm not drawing these lines perfectly straight, but I could fold it through that one, and I could fold it through the last one as well. So in this particular figure, this pentagon, I could fold it through all of the vertices and I would end up with a line of symmetry. So it has line symmetry. Again, you can call it line or reflectional. It means the same thing. And how many lines? In this case, there's 5 lines. Okay, for B, I cannot fold this in half and get a symmetric figure. If I were to fold it, if I tried to fold it through this vertex, when I folded it over, this side is much larger than this one, so they wouldn't line up perfectly. I can try a few different things. I could try to fold it this way, but they're not going to line up. I could try folding it this way. It's not going to line up. So this one, it does not have line symmetry. Okay. All right, I'm going to stop the video